In statistics and quantitative research methodology, various attempts have been made to classify variables and thereby develop a taxonomy of levels of measurement or scales of measure. Perhaps the best known are those developed by the psychologist Stanley Smith Stevens. He proposed 4 types: nominal, ordinal, interval, and ratio. Typology. Stevens proposed his typology in a 1946 Science article titled On the Theory of Scales of Measurement. In that article, Stevens claimed that all measurement in science was conducted using 4 different types of scales that he called nominal, ordinal, interval, and ratio, unifying both qualitative and quantitative. The concept of scale types later received the mathematical rigor that it lacked at its inception with the work of mathematical psychologists Theodore Alper, Louis Narens, and Duncan Luce. As Luce wrote, nominal scale, the nominal type, sometimes also called the qualitative type, differentiates between items or subjects based only on their names or categories and other qualitative classifications they belong to. Thus dichotomous data involves the construction of classifications as well as the classification of items. Discovery of an exception to a classification can be viewed as progress. Numbers may be used to represent the variables, but the numbers do not have numerical value or relationship. Examples of these classifications include gender, nationality, ethnicity, language, genre, style, biological species, and form. In a university you can also use Hall of Affiliation as an example. Mathematical operations, set membership, classification, categorical equality, and equivalence are all operations which apply to objects of the nominal type. Central tendency, the mode, that is the most common item, is allowed as the measure of central tendency for the nominal type. On the other hand, the median, that is the middle-ranked item, makes no sense for the nominal type of data since ranking is meaningless for the nominal type. Ordinal scale, the ordinal type allows for rank order by which data can be sorted, but still does not allow for relative degree of difference between them. Examples include, on one hand, dichotomous data with dichotomous values such as sick versus healthy when measuring health, guilty versus innocent when making judgments in courts, wrong-false versus right-true when measuring truth value, and, on the other hand, non-dichotomous data consisting of a spectrum of values, such as completely agree, mostly disagree, completely disagree when measuring opinion. Central tendency, the median, that is middle-ranked, item is allowed as the measure of central tendency. However, the mean as the measure of central tendency is not allowed. The mode is allowed. In 1946, Stevens observed that psychological measurement, such as measurement of opinions, usually operates on ordinal scales. Thus means and standard deviations have no validity, but they can be used to get ideas for how to improve operationalization of variables used in questionnaires. Most psychological data collected by psychometric instruments and tests, measuring cognitive and other abilities, are ordinal, although some theoreticians have argued they can be treated as interval or ratio scales. However, there is little prima facie evidence to suggest that such attributes are anything more than ordinal. In particular, IQ scores reflect an ordinal scale, in which all scores are meaningful for comparison only. There is no absolute zero, and a 10-point difference may carry different meanings at different points of the scale. Interval scale, the interval type allows for the degree of difference between items, but not the ratio between them. Examples include temperature with the Celsius scale, which has an arbitrarily defined 0-point, date when measured from an arbitrary epoch and direction measured in degrees from true or magnetic north. Ratios are not allowed since 20 AA degree Celsius cannot be said to be twice as hot as 10 AA degree Celsius, nor can multiplication division be carried out between any two dates directly. However, ratios of differences can be expressed. For example, one difference can be twice another. Interval-type variables are sometimes also called scaled variables, but the formal mathematical term is in a fine space. Central tendency and statistical dispersion, the mode, median, and arithmetic mean are allowed to measure central tendency of interval variables, while measures of statistical dispersion include range and standard deviation. Since one can only divide by differences, one cannot define measures that require some ratios, such as the coefficient of variation. More subtly, while one can define moments about the origin, only central moments are meaningful, since the choice of origin is arbitrary. One can define standardized moments, since ratios of differences are meaningful, but one cannot define the coefficient of variation, since the mean is a moment about the origin, unlike the standard deviation, which is a central moment. Ratio scale. The ratio type takes its name from the fact that measurement is the estimation of the ratio between a magnitude of a continuous quantity and a unit magnitude of the same kind. A ratio scale possesses a meaningful zero value. Most measurement in the physical sciences and engineering is done on ratio scales. Examples include mass, length, duration, plane angle, energy and electric charge. Ratios are allowed because having a non-arbitrary 0 point makes it meaningful to say, for example, that one object has twice the length of another. Very informally, many ratio scales can be described as specifying how much of something or how many. The Kelvin temperature scale is a ratio scale because it has a unique, non-arbitrary 0 point called absolute zero. Central tendency and statistical dispersion. The geometric mean and the harmonic mean are allowed to measure the central tendency, in addition to the mode, median, and arithmetic mean. The studentized range and the coefficient of variation are allowed to measure statistical dispersion. All statistical measures are allowed because all necessary mathematical operations are defined for the ratio scale. Debate on typology. While Stevens' typology is widely adopted, it is still being challenged by other theoreticians, particularly in the cases of the nominal and ordinal types. Duncan objected to the use of the word measurement in relation to the nominal type, but Stevens said of his own definition of measurement that the assignment can be any consistent rule. The only rule not allowed would be random assignment, for randomness amounts in effect to a known rule. However, so-called nominal measurement involves arbitrary assignment, and the permissible transformation is any number for any other. This is one of the points made in Lord's satirical paper on the statistical treatment of football numbers. The use of the mean as a measure of the central tendency for the ordinal type is still debatable among those who accept Stevens' typology. Many behavioral scientists use the mean for ordinal data, anyway. This is often justified on the basis that the ordinal type in behavioral science is in fact somewhere between the true ordinal and interval types. Although the interval difference between two ordinal ranks is not constant, it is often of the same order of magnitude. For example, applications of measurement models in educational contexts often indicate the total scores have a fairly linear relationship with measurements across the range of an assessment. Thus, some argue that so long as the unknown interval difference between ordinal scale ranks is not too variable, interval scale statistics such as means can meaningfully be used on ordinal scale variables. Statistical analysis software such as SPSS requires the user to select the appropriate measurement class for each variable. This ensures that subsequent user errors cannot inadvertently perform meaningless analyses. L. Thurstone made progress toward developing a justification for obtaining the interval type, based on the law of comparative judgment. A common application of the law is the analytic hierarchy process. Further progress was made by Georg Rasch, who developed the probabilistic Rasch model that provides a theoretical basis and justification for obtaining interval-level measurements from counts of observations such as total scores on assessments. Another issue is derived from Nicholas R. Krisman's article Rethinking Levels of Measurement for Cartography, in which he introduces an expanded list of levels of measurement to account for various measurements that do not necessarily fit with the traditional notions of levels of measurement. Measurements bound to a range and repeating, graded membership categories, and other types of measurement do not fit to Stevens' original work, leading to the introduction of 6 new levels of measurement, for a total of 10, nominal, graded membership, ordinal, interval, log interval, extensive ratio, cyclical ratio, derived ratio, counts and finally absolute. The extended levels of measurement are rarely used outside of academic geography. Scale types in Stevens' operational theory of measurement. The theory of scale types is the intellectual handmaiden to Stevens' operational theory of measurement, which was to become definitive within psychology and the behavioral sciences, despite Michael's characterization as its being quite at odds with measurement in the natural sciences. Essentially, the operational theory of measurement was a reaction to the conclusions of a committee established in 1932 by the British Association for the Advancement of Science to investigate the possibility of genuine scientific measurement in the psychological and behavioral sciences. This committee, which became known as the Ferguson Committee, published a final report in which Stevenson's scale was an object of criticism, that is, if Stevenson's scale genuinely measured the intensity of auditory sensations, then evidence for such sensations as being quantitative attributes needed to be produced. The evidence needed was the presence of additive structure, a concept comprehensively treated by the German mathematician Otto Haar, paragraph LDER. Given that the physicist and measurement theorist Norman Robert Campbell dominated the Ferguson Committee's deliberations, the committee concluded that measurement in the social sciences was impossible due to the lack of concatenation operations. This conclusion was later rendered false by the discovery of the theory of conjoint measurement by Debreu and independently by Luce and Tukey. However, Stevens' reaction was not to conduct experiments to test for the presence of additive structure in sensations, but instead to render the conclusions of the Ferguson Committee null and void by proposing a new theory of measurement. Stevens was greatly influenced by the ideas of another Harvard academic, the Nobel laureate physicist Percy Bridgman, whose doctrine of operationism Stevens used to define measurement. In Stevens' definition, for example, it is the use of a tape measure that defines length as being measurable. Critics of operationism object that it confuses the relations between two objects or events for properties of one of those of objects or events. The Canadian measurement theorist William Rosebaum was an early and trenchant critic of Stevens' theory of scale types. See also, inter-rater reliability, Cohen's kappa, Hume's principle, logarithmic scale, Ramsey-Lewis method, notes. References. External links.